Alright folks, today most of what we're going to be doing is review. We're going to talk about all the methods we've used to solve quadratics, both last chapter and this chapter. That means factoring, completing the square, using the square root method by itself, or quadratic formula, what we learned last time. So what we want to think through every single time is which method would be best to save us time, because there are two of these that work every single time. Completing the square works every single time, but we only talked about when A is 1. And it's nicer when B is even, but you can actually solve. Quadratic formula also works for every single type of problem, but that doesn't necessarily make it the best. So the order we want to look at these in is we want to start with, I know it says 1 square root method, but I still like to try to factor first because a lot of times with square root method, kind of like what you have here, you could factor if you wanted to, equal to 0 sometimes. So I'm going to think about this factor first if you can. If you can't, and there's only 2 terms, then we can go to square root method. That's if maybe this was a number 8, something that wasn't a perfect square. And then once we decide neither of those work, so we have 3 terms, we can complete the square, again, only if it looks like a regular x squared, and we're only going to do it if b is even, because when we split that into 2 parts, we want it to not be a fraction. Just makes it a little easier to work with if we go quadratic formula route instead. Okay, so last resort will be quadratic formula. This is going to be either when none of those work, or we're spending way too long trying to factor it because the numbers are too big to work with reasonably. Okay, so we'll do a few of these together, and then I'll let you try some on your own. So here, we're going to always start looking to factor. So we've got 3 terms here. We would look for a GCF, and there's nothing there. And because this is a regular x squared, we're looking at the factors of 10 that add to be 7. So the only factors of 10 are 1 and 10, and 2 and 5. And we want to combine to be 7, so this actually is factorable with a positive 2 and a positive 5. Because this is x squared, we can skip to x times x is the only way to get there. And 2 times 5 will go in the second place to get to that 10, and we already decided signs were positive. You always want to make sure that this factored form checks with the original. First term times first term should get you back to that. That works out. And then second term times second term should get you there. The middle terms come from our diamond there, but they add up to that 7, but it's from your outside and your inside being added together. So our factored form is good, giving our 2 solutions of -2 and -5. Okay. Next one, we're going to do the same process. Since it's x squared, we don't have a common factor here. So we'll start out trying to factor with a 12 and a -6. Okay, so my factors here, 1 and 12, 2 and 6, 3 and 4. None of those are going to combine to be a -6. In order to be negative, all of these have to be negative. But even then, it's not going to give us a -6, which means factoring does not work. So now we're at the point where we think about square root method, completing the square, or quadratic formula. In this case, we've got 3 terms, so we're going to complete the square or quadratic formula. Because A is 1 and B is even, this one is one that will be not so bad to complete the square on. So remember, completing the square means this last term has to be a perfect square. It's not. So step 1 is move that to the other side. Just subtract it over. And we're going to complete this into a perfect square trinomial by adding in a term. Okay, and they call that C a lot of times. Okay, but I showed you, you can think about this by setting up a box, where this is x squared, and this -6 is coming from the diagonal, -3 and -3, which means my perfect square comes from -3 squared, or -3 times -3 is 9. So here I've got x squared minus 6x plus 9, then equals on the same, or other side, we see the same thing. Okay, this left side is going to factor, Use your box if it helps doing GCF. Minus 3, x comes out, minus 3. That's where our x minus 3 squared comes from. And then on this side, we've got a negative 3. Now, I want you to get to a point where you recognize it here, but you can also take one more step. When you take the square root of a negative number, you're not going to have any real solutions. So this one, no solution. Okay, so this one was factoring, specifically our easy factoring, when we just skip to x and x, and this one was complete the square. Okay, looking at the next one, there is a GCF. Now from last chapter, we wanted to factor out that GCF using parentheses, but in the or in the case of equations, you can just divide off your GCF. Because we can do that to all three pieces, the multiplication property of equality allows us to do that. So now I've got x squared minus 25 equals 0. Okay, and this is something that has two terms. So with two terms, if one is x squared and one is a constant, you can use the square root method. But like I said, I like to factor first. This is one that we can factor because those are perfect squares pretty easily. Just take the square root of the first term, and then the square root of the second term, and decide on signs. To multiply to get to a negative, we need one positive, one negative, and then our middle term, since it says -5 and +5, go away. Okay, so that's my factored form. Gives me a -5 and a +5. Okay, but I do want to show you for this one, okay, if this was not a perfect square, we would have wanted to, at this point, add over that 25, square root both sides. We still get two answers because remember when you take the square root, just like over here, we didn't get to it because it was no solution. But when we take that square root, we automatically tuck that plus or minus in front. So same answer either way. So this would be factoring, specifically a difference of squares, or square root method. Your choice. Okay. These ones all look a little bit messier because there's a number in front, but you want to start with the same first process. This is the first one that isn't equal to 0, so I want to subtract that over. 2x squared minus 1x minus 5 equals 0. So first thing we want to do is try to factor. There's not a GCF, which means in order to factor, I would set up my box, 2x squared and -5. So I'd be looking at the factors of -10x squared that add to -1. Okay? In this case, same idea, we're looking for factors that might work. 1 times 10, 2 times 5, but none of those are going to combine to be -1, so it's not factorable. We've got 3 terms, so we have to complete the square or quadratic formula. This is one where we want to use the quadratic formula because this a value is not equal to 1. So once you decide quadratic formula, I need you to write a equals b equals c equals. Okay, and then go from there. As a reminder, the quadratic formula looks like opposite of b, plus or minus, big square root symbol, b squared minus 4 times a times c, all divided by 2 times a. Okay, so I'm going to let you pause the video and substitute in those values for me. Okay, so this one would be 1 plus or minus. Remember, for this one, you always have to have a positive number. -1 squared is -1 times -1, so it's positive. And a was 2, c is -5. Big division, 2 times 2. Okay, if you're using your calculator for this, remember, do not type in the square root. Type in everything underneath it. 1 minus 4 times 2 times that -5. We get 41. And we can do some rewriting. So at this point, we've got 1 plus or minus the square root of 41 all over 4. But we have to, at this stage, always look at this to make sure it's as simplified as possible, because sometimes we have some extra reducing that we need to do. Okay, so the square root of 41, we're looking for a perfect square that goes into it. Since 41 is prime, that does not simplify at all, and that means we cannot reduce with our numbers in front. So our two answers are 1 plus the square root of 41 over 4, and 1 minus the square root of 41 over 4. And that was quadratic formula. Okay. There are two more problems, and what I want you to do is pause the video and work on those. You can work on them with someone else if you'd like. Okay, and then we'll come back together to check them. Okay, first step is GCF. In this case, hopefully you recognize that there was an x along with the 3 that you could factor out. Okay, so this one is factored after the GCF because there's no squared anymore. If you missed the x, you would have probably gotten stuck at that point. Okay, but from here, this says 3x equals 0 or x plus 3 equals 0. So my two answers are 0 and negative 3. Okay, so that was another factoring one, specifically just GCF. Okay, over here, when we're looking at this problem, the 12x squared, the 7x, and the negative 21, there's not a GCF involved. So if you were going to factor, you would have to set up a box, 12x squared, negative 21, and in our diamond, we would have to look at the factors of the 12 times the negative 21, which is negative 252. The add to be 7. And you might spend quite a bit of time trying to find the ones that may or may not work. Okay, so this is a one where we were talking about, I'm going to go ahead and go way back to the first thing. This is one where maybe if our numbers are too large and it's going to take a while to find the factors that may work, you might want to instead try to do quadratic formula because those numbers are so big in the diamond there. Okay, so at this point, I'm going to show you quadratic formula and how that works, and how to recognize from your answers from quadratic formula if that was actually factorable or not. So if I let A be 12, B equals 7, and C equals negative 21, opposite of B would be negative 7, plus or minus. B squared would be 49, minus 4 times A times C, watching out for signs, divided by 2 times A. Okay, so again, we're going to put in our discriminant. Remember that vocab word from last time. It's the expression underneath that square root. And I'm not typing the square root in, just in case it's ugly. Okay, so this one was 1057. And that may be a number that you don't recognize as a perfect square, if it is one. So I'm going to type that in, and that tells me it wasn't. Because this ended up being an ugly number, that means we would have spent forever trying to find factors only to not find them at all. Okay, so it was not factorable in this case. So then, what we're going to do now is try to find a perfect square that goes into it. When this thing ends in a 7, it looks like it's something that could be prime, but you still want to spend some time to check through your numbers to see if that's actually true. So take time to divide this by perfect squares, your 4, your 9, your 16, and so on, specifically the odd numbers since it ends in that strange value, to see if you can come up with any perfect squares that may actually go in evenly. Now, if 9 doesn't go in, 81 won't go in, but we could try maybe 49. It's not going in evenly. This, in fact, is a number that does not break down, but I do want you to spend time looking through that. Okay, so make sure you're checking for that when you're doing your work. So negative 7 plus or minus, leaving it like that because we can't simplify. And then on the bottom we have 24. So again, because we can't simplify that, even if we could reduce those numbers, which we can't, we're not allowed to because it has to go into all three of that triangle. So my first answer is negative 7 plus the square root of 1057 over 24. And my second answer is negative 7 minus that value. So another quadratic formula. Okay. I want you to go through and decide which method would be best, just thinking through those steps that we were talking about. Okay, so pause the video and try 7 through 10 for me. Okay. All of these you want to try to factor, but you may not be able to factor all of them. Okay, so here, 17 and 33, when you multiply those numbers together, it's really quite large. So even if you wanted to factor, because there's not a GCF, maybe you don't want to because that it's just going to be too time consuming. So this is a quadratic formula one. Okay, this one, factors of 12 that add to be 7, 2, and 6 don't work. 1 and 12, I'm going to go ahead and list them out to the side here. Okay, but 3 and 4 do, so this one is one you can factor. All right, this one, when we have a negative 3 trying to get to 8, the only factors are 1 and 3. That's not going to get you there. So this is where we would take the time to think, is this a square root method, a complete the square, or quadratic formula? Because this says regular x squared and this is even, that's a complete the square problem. And that last one was the square root method because we can't factor when this is not a perfect square with two terms. You want to instead move that 5 over and square root it. Okay. Last thing we're going to do today is review a little bit with Newton's law. Okay, the focus of this is actually going to be talking about when answers don't really come out perfectly nice, because in real life that's not as practical. Last chapter when we looked at Newton's law, we always solved by factoring, and we got nice numbers like a second, 2 seconds, a quarter of a second, things like that. Realistically, it's just most often not going to happen that way. So these are ones where if we can factor it easily after a GCF, we will, but otherwise we're just going to use quadratic formula to solve, because a lot of times our answers won't be nice. So let's review by talking about the pieces of the quadratic formula, of Newton's law, which we have up here. This, remember, is a constant, and then right below that's our velocity, and then we remember hopefully the subscript, this h naught, but that just means the start height from whatever object we're working with. So it says Connor was playing catch with Cole the other day and came up with the equation for the hardest ball he could throw. This equation looked like this, and that tells us that the initial velocity was 80, and our initial height where Connor was throwing the ball from was 6. Okay, so what we're going to do is talk about some questions here. Would the parabola open up or down? Okay, reminder, this is the shape, and we want to go up or down based on the sign of A. So this one is going to go down. And I'm just going to remind you that's because A is negative. Okay. And then we're going to find the vertex of the parabola. It's a good review from our first section. Remember, the vertex can be found by the same equation as the axis of symmetry. That's your opposite of B over 2A will give you the x value, and then we'll have to sub it in to find the y value. Okay, from there, though, we have to recognize what the A, B, and C are. So up at the top, let's go ahead and write that out. First coefficient is negative 16, B is 80, and C is 6. So our opposite of B would be negative 80 over 2 times the negative 16, and then we simplify. It's really important that you simplify this bottom part first. So negative 80 over negative 32. And then we can just put that in our calculator because it's probably not nice. It isn't in this case, but could be a simple fraction, or maybe it's nicer as a decimal depending on the problem. So in this case, it's nice as a decimal. We'll leave it like that. If it's not nice as a decimal, you want to change it to a fraction. So this is 2.5. Okay, so that means when we think about our parabola, This number right here is 2.5. But that point has an x value and a y value. So now it's our job to find the y value. And that just comes from plugging this in. Our x value is actually t for this one. So we're going to plug this in the equation everywhere we see a t. I recommend you write this down so you don't forget, because a lot of times when we were doing this, we just use our table to sub it in. But if we're just finding one value, it's faster to just plug it in to the equation and toss that in your calculator. So negative 16, then our 2.5 gets squared. Make sure you're using parentheses around this. That's going to be important. Okay. And that tells us 106. So the vertex is 2.5106 as an ordered pair. Okay. The y-intercept, as a reminder, is always 0, c. So our c value is 6, but also when we graph these last chapter, remember the start height is where you put your first number over here, and so that was by definition our y-intercept. Okay, so 0, 6. Okay, now we're going to put it all together for our graph. So we know that this is talking about time in seconds, all Newton's laws, and then the height is going to be in feet for us. Now, last chapter, we never found the vertex, so we never knew how high this was, but now we know the actual shape of this expression here is a parabola, and it's measuring not the path of the ball, but instead how the height changes over a given interval of time. So we know after 2.5 seconds, it's gone up to a height of 106. Okay, so we're going to put that on there. It's important. And then scale-wise, I put this on a little bit early, scale-wise, this 6 should be quite a bit lower. Okay. So over here, I know that 2.5 has to show up, but I'm going to go ahead and count by nice numbers. 1, 2, 3, 4, 5, 6. That's probably enough, because remember 2.5 is your halfway point here. So label that. Okay, so 2.5, we're going to our maximum height. I know I'm starting here, and then we have to end somewhere, but we don't know that information yet. Okay, so we're going to actually leave it at that for right now, so that we can figure out the final part to answer this question. It says, what is the maximum height of the ball? We know that from our path is the 106. Okay. So anytime you see this maximum, it's talking about the vertex. You just have to know which part of the vertex it's asking you about. So maximum itself is the maximum height is y. And how long is talking about seconds, that's our x. Okay, so it took us 2.5 seconds. Then it says, after how many seconds did the ball hit the ground? So again, they gave us some information. The ground is a y value because it's talking about the height. But from last chapter, hopefully you remember, that is always going to be 0. So our original equation, instead of this ending height of h, we're going to write 0 equals and go solve. Okay, from here, this is what we're going to do. We're going to try to still look for a GCF because that's going to help us with our numbers here. We're still going to try to get an a value that's positive because that helps. And we're still going to try to factor if we can, but if it's not easily done, then we will just move on to quadratic formula. Okay, so starting out here, I'm going to get rid of this negative, multiplying by -1. So I'll get minus 80, and then minus 6 equals 0. And then we're going to look for a GCF. Now 16 doesn't go into all of them because of this 6. Okay, but we could look at something smaller. 4 doesn't go in. 2 will go into each of them. And remember, we can just divide this off on all pieces because it's an equation. So now I've got 8t squared minus 40t minus 3 equals 0. And now, if I wanted to factor, it'd look like -24 t squared, trying to be negative 40. And those numbers aren't terribly large, so that wouldn't be something that would be terrible to find if it was factorable. Okay, but if we think about the numbers, 1 and 24 are the furthest apart from each other, and we're looking for a difference of 40. So this is not going to be factorable, even if we tried. Okay, but it wouldn't take you long to go through all of them to figure that out if you were listing them. So now we're going to use quadratic formula. And we're using these smaller numbers rather than the larger numbers. That's a big benefit of doing GCF first. Okay, so from here, opposite of b is 40, plus or minus. Then we're taking this and squaring it. Use your calculator if you need to. Make sure that is a positive number always. Minus 4 times a times c, all divided by 2a. And our a was 8. Okay, we're going to type in that discriminant, 1600 minus 4 times 8 times negative 3 gives us the square root of this. Okay, not a nice number. We knew that because it wasn't going to be factorable. This is one that I'm not going to have you spend the time to write it exactly, because even if I could break this down, it's not going to give me a nice answer. When I'm talking about time in seconds, we want the decimal, we want the approximate value. Okay, so we're not going to spend time simplifying that 1696. We're just going to rewrite it and then find our two answers. Okay, so here's what I mean by that. We know that the first answer is 40 plus this ugly number over 16. And the second answer is 40 minus that ugly number over 16. So in our calculator, that's precisely what we're going to type. So here, we're going to take our 40 plus that number. Make sure when you're typing this in that after you do the numerator, you hit enter before dividing by 16. That way you're taking care of order of operations. So my first answer is about 5.1. Okay, we're going to do the same thing on the second one. 40 minus that number. Again, it's not going to be very nice, but we're going to hit enter after that before dividing by 16. And that's about negative 0.1. Okay. Only one of these answers of the two is going to make sense for our problem. We're talking about hitting the ground, so this 5.1 is more reasonable. Let's put it on our graph. And now we can see the path of our parabola a little bit nicer. Okay. So here, this was our 0, 6. This point that we found on the y-intercept. This was my ordered pair of the vertex, which was 2.5106. And this last answer was my x-intercept that applied. It was about 5.10. So this one, it said after how many seconds did the ball finally hit the ground? The ball hit the ground after about 5.1 seconds. Okay, so long process here, but going through this is going to kind of help tie together a lot of the steps that we've been working with. Okay, so let's look at this next one. Okay, what I'm going to have you do is try to answer questions 15 through 19. Okay, that way you can review some of the stuff from earlier in the chapter. Use your example that we just talked about to do that. Okay, pause the video, try those, and then we'll go over them and talk through that last question. Okay, this one's going to open down again, always for Newton law. Vertex comes from opposite of b over 2a. Opposite of b here is negative 1,000. Divided by 2 times a. Remember, you have to simplify that first, so it's negative 32. And that is a decent decimal, so we're going to leave it. But we have to go find the y value by subbing it in this equation. So you're taking negative 16 times that squared, and then plus 1,000 times that again, and then plus 6. So 15,631. Okay. Y-intercept is just the c value, so 0, 6. And we're going to make a rough sketch, but again, we can't put everything yet. We just know some of the pieces. So the height is in feet, starting real low at 6 and ending super high at that 15,631. But I don't know how long it's taking other than this 3125 being in the middle. Okay, so I'm going to come back to the scale for that even while we talk about our final value. Okay, so the maximum height was at 15,631 feet, and it took 31.25 seconds to get there. Okay, because again, this is always seconds along the x-axis. So now to hit the ground, we're thinking 0 equals, because remember, the ground is a height of 0, or y equals 0. Okay, and for this one, I'm going to have you do 2 steps in one. Save us a little bit of space. We're going to get rid of this negative and take out a GCF at the same time. So here, when we know that all of these are even, and again there's a 6 in the way, we're just going to divide by a negative 2 on all these pieces, and that'll get rid of both our problems without taking up as much room. So this is a positive 8t squared, a negative 500t, and a negative 3. And I like my equal 0 on that side. Okay, from there, again, this negative 24 is too small to possibly work with 500, so this is a quadratic formula problem. Okay, so quadratic formula, we need to know the a, the b, and the c. And we want to use these smaller numbers because we worked hard to find them. Okay, from there, opposite of b looks like 500 plus or minus b squared. You can put it in your calculator if you want. Okay, but remember this is always positive. Let me show you something. If you put this in your calculator as negative 500 and then hit squared, it's not going to give you the right answer because you have to make sure that you're squaring the sign of that thing as well. So if you're typing it in, make sure you're doing it that way rather than writing it without the parentheses. Okay, be careful on that. Rest of it, 4 times a times c. Big division sign, 2 times a, which is 8 for us. Okay, we're starting out with the thing underneath the square root. So I'm taking that 25 squared, or excuse me, the 500 squared, minus 4 times 8 times negative 3. And we're just leaving that under the square root. Remember, it's not worth it to break that down. It would take forever. See if I copied that right. 2 zeros. And we're just going to rewrite it. 500 plus that number over 16. And 500 minus that number over 16. So we can type those in separately. Remember, after you type in that value, hit enter before you divide. Take care of order of operations. So about 62.5 for the first one. Second one, same way. 500 minus. Hit enter, then divide by 16. Now this one will take a couple decimals not to round to 0. So I'm going to do about negative 0.01. Really, really small over here. So when we think about this graph, I need to get to 60 plus. So I'm going to count by tens. So I had my nice point of this 31 way at the maximum. And label that. And then I ended up, must be at this one, the 62 for my x-intercept. So from there, I can make my parabola and answer the question. So it said, how long did it take for the bullet to hit the ground? Okay, it took the bullet approximately 62.5 seconds. And that's it. Okay. If you have any questions on your homework, okay, please let me know. But please practice as you go, figuring out the best method, factoring first, then complete the square, then quadratic formula.